For today's lesson, our focus standard comes from Grade 7, Ratios and Proportional Relationships, Standard 1, Compute Unit Rates Associated with Ratios of Fractions. Our topic comes from our Proportional Relationships unit, Unit Rates with Complex Fractions. Our essential question is, how do we use what we know about dividing fractions to calculate unit rates with fractions? So take a moment pausing the video if you need to copy down the topic and essential question in your header, along with today's date, set up your question column and your note column, and resume the video when you're ready to begin. So as our essential question hints at, we are going to start by talking about dividing fractions. So a little bit of review about dividing fractions. You might remember our key phrase, keep, change, change, where we keep the first fraction, change the operation to multiplication, and change the second fraction to its reciprocal, meaning we flip it. So keep that in mind because we're going to be using that to deal with complex fractions, which are two fractions that make a fraction. There's a fraction in the numerator and a fraction in the denominator. So let's go ahead and look at our first example. Ms. Bauer uses 2/5 of a bottle of paint to cover 1/3 of a canvas. How much of a bottle of paint does it take to cover the whole canvas? Now, thinking about that question, you might already have some ideas. So let's go ahead and talk our way through it. In my mind, there's about 3 steps to thinking about this process for these types of questions. First of all, we have to interpret the question we're being asked to think about it as the unit rate. What are the two quantities that they want us to compare? Then we're going to set up our calculations to do that, and then we'll state our solution in a complete sentence. So in our question it says, how much of a bottle of paint does it take to cover a whole canvas? Well, a whole canvas means 1, right? 1 whole canvas, which is a unit rate. Our second quantity is always a value of 1. So it must mean something like this if we were to interpret it. They want to know, what is the fraction or amount of a bottle of paint per canvas for, and we might even insert a 1 here, for one canvas, right? Because it said a whole canvas. So now that we can interpret this as a unit rate, it helps us set up our calculations. We know what our numerator is, and we know what our denominator is. Our numerator is going to be the amount of paint we know that she uses to cover. This will be our denominator, what we know about the canvas. So for our second step of setting up the calculations, it's going to look something like this perhaps. 2/5, which is the amount of paint, right? That's the bottle that is listed first, that's our numerator, covers 1/3 of a canvas. So bottle of paint to the canvas. But we want to know, how much does it take to get to 1 whole canvas? Well, some of you might right away see a factor here that would get us to 1. Do you see it? Yeah, some of you might notice that if we took 1/3 and we multiplied it by 3, we'd get to 1. And if we're going to keep these fractions equivalent, then we'd also have to multiply by 3 in the numerator. So we know that 1/3 times 3 is 1. So we also then need to multiply 2/5 by 3 over 1. So what do we get when we multiply our fractions here? Well, if you said 6/5, I'd agree with you. So it must mean that it takes 6/5 of a bottle of paint to cover 1 whole canvas. But I want you to think about it another way too. We wrote our setup this way, where it was 2/5 of a bottle of paint divided by 1/3 a canvas. We could have also written it this way, and following the rules for dividing fractions, we would keep the first fraction, change division to multiplication, and flip our second fraction. So it would become this problem. Well, notice that that's exactly what we ended up doing right here. We took 2/5 and multiplied it by the reciprocal of the bottom fraction. And if we multiply straight across, we're going to get the same answer, because 2 times 3 is 6 and 5 times 1 is 5. So we get to the same answer. So sometimes it's easy to see what we need to multiply by to get a unit of 1. But when it's not easy to see, this method will be really helpful. And finally, we want to state our solution in a complete sentence. So we could say that Ms. Bauer uses 6/5 of a bottle of paint per canvas, just filling in that blank from when we restated the question as a unit rate. Let's try the next example. Mrs. Bond uses 1/7 of a pack of paper to make copies for 1 3/4 of her classes. What fraction of a pack of paper does she use for each class? So again, we're going to use the same 3 steps. Pause the video now if you can to restate our question, what fraction of a pack of paper does she use for each class as a unit rate? Well, if you said she uses some amount, right, that's what we're trying to figure out, of a pack of paper per class, I'd agree with you. Notice we're making use of that word per. And so it was pack of paper was listed first, and it's for each class. We're talking about one whole. So now we're ready to set up our calculations. So using our restatement of the question as a unit rate, I just followed the same format. Since we're comparing pack of paper to a class, I know that it's 1/7, so a pack of paper, so that goes in my numerator since it's first, over 1 3/4 of a class. Can you figure out a way to where we can calculate this out? In this instance, it's not easy to see a factor where we can get to a unit of 1, so it might be best to use that second method. Again, sometimes it's helpful to realize that this fraction bar means to divide, so we're really being asked to take 1/7 divided by 1 3/4. But before we can do our calculations, we can't divide by a mixed fraction where we have a whole number and a fraction. We need to turn it into an improper fraction. So go ahead and do that down below here. Well, we're keeping the 1/7. We're still trying to think about it as a division problem because we needed to turn this into an improper fraction. And since 4 times 1 is 4, plus 3 is 7, 1 3/4 is equal to 7/4. Now we're ready to calculate this using keep, change, change. Go ahead and extend the problem and see if you can complete these calculations. So we kept our first fraction, 1/7, changed division to multiplication, and used the reciprocal or flipped our second fraction. So now it's 4/7. So as long as you have this set up, did you go ahead and multiply across to find our answer? That's right, 4/49. So now we just have to state our solution in a complete sentence. We were trying to figure out what part of a pack of paper does Miss Bond use for one class, and by doing these calculations, we found our answer. So we could state that Ms. Bond uses 4/49 of a pack of paper per class. Let's check out our third and final problem. For number 3, Mr. Olson covers 2/3 of his yard with 4/5 of a load of mulch. Mulch is like bark that we cover yards with to kill like the grass or to put around flower beds. So he's covering 2/3 of his yard with 4/5 of a load of mulch. And they're asking us what fraction of a load of mulch does it take to cover his yard, meaning his whole yard. So go ahead and pause the video, work your way through these 3 steps, and then check back when you're ready to compare your work with mine. Well, If you restated the question of what fraction of a load of mulch does it take to cover his yard as being leaving a blank here for trying to find that fraction or that amount of mulch per yard, his one whole yard, I'd agree. Then taking the information from the question and following this order, we know that he used 4/5 of a load of mulch, that's our numerator, divided by 2/3 of his yard. We could also write it out this way, and it would be an equivalent way to write the problem. So as long as your setup is correct, go ahead and finish the calculations if you haven't done so already. We would keep the first fraction, change division to multiplication, and flip our second fraction. Then we're ready to multiply straight across. In doing so, we get 12/10. But did you notice this fraction can reduce? We can divide both 12 and 10 by the common factor of 2. So it simplifies down to 6/5. We always want our answer in the simplest form. So lastly, we just need to state our answer in a complete sentence. In doing this work, we fill in the blank. It took 6/5 of a load of mulch per yard. To state it as a more complete sentence, we'd say Mr. Olson uses 6/5 of a load of mulch to cover his yard.